Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on intermolecular forces in covalent compounds. Previously, we discussed molecular shape and molecular polarity. We learned that the shape of molecules, as well as their bond polarities, affects the dipole moment of molecules. We learned that if the polarities of bonds within a molecule are arranged in a way so as to counterbalance one another, then the molecule will have a dipole moment of 0. However, if the polarities do not counterbalance one another, then the geometrical symmetry of the molecule will be uneven, and it will have a dipole moment. In our lesson today, we will define the term intermolecular force. We will list the different types of intermolecular forces, and we will explain dipole-dipole interactions. We will also look at some examples of dipole-dipole interactions. Are you ready to begin? Within any sample of matter, there are two different types of electrostatic forces at work. These two forces are intramolecular and intermolecular. Intramolecular force makes a chemical bond, which includes ionic, covalent, and metallic bonds. It is a force that exists within any particle, be it a molecule or a polyatomic ion that holds the atoms together, and it affects the chemical property of that species. By contrast, intermolecular forces exist between particles and influence the physical properties of that species. Intermolecular forces occur because of the attraction that exists between ions and molecules. These forces are quite weak compared to intramolecular forces. This is due to the fact that intermolecular forces often involve lower charges that are further apart. Intermolecular forces have charges that are low and far apart because they exist between non-bonded atoms in adjacent molecules. Students, can you list some intermolecular forces? Please try to list some now. Also, draw an example of intermolecular forces and intramolecular forces.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. I wonder how many different types of intermolecular forces you were able to think of. Let us list them together. Perhaps you thought of dipole-dipole forces or hydrogen bonding. You might have also mentioned London or dispersion forces. Great work, students! All of these are correct and are the most important types of intermolecular forces. Let us continue our lesson by discussing dipole-dipole forces. We will study hydrogen bonding and London dispersion forces in our following lessons. When polar molecules are brought close to one another, their partial charges act as tiny electrical fields that orient them and bring about dipole-dipole forces. In other words, the partially positive end of one molecule attracts the partially negative end of another molecule. In an iodine monochloride molecule, the more electronegative chlorine atom bears the partial negative charge. The less electronegative iodine atom bears the partial positive charge. The partially positive iodine end of one iodine monochloride molecule is attracted to the partially negative chloride end of another iodine monochloride molecule. As you can see here, we used a dashed line to represent the intermolecular attraction between molecules. This is because these forces are not as strong as chemical bonds. This interaction can be seen in hydrogen chloride molecules as well. These interactions align the molecules to increase their attraction while reducing their potential energy. For compounds of approximately the same mass and size, greater is the dipole moment, greater is the dipole-dipole forces between their molecules, and thus greater is the energy required to separate their particles. The weaker the dipole-dipole forces, the lower the boiling point. The higher the dipole-dipole forces, the higher the boiling point. Let us look at an example. The molecules of methyl chloride and ethanol have a similar size and mass. However, methyl chloride has a smaller dipole moment than ethanol. As a result, less energy is needed to overcome the dipole-dipole forces between methyl chloride molecules. So, it boils at a lower temperature than ethanol. Dipole-dipole forces also give the polar cis isomer of dichloroethene a higher boiling point than dichloroethene's nonpolar trans isomer. Students, what are intermolecular forces? What are dipole-dipole interactions? Please write your answers on a piece of paper, and I will see you in a few moments.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, students. I am sure that you had no problem answering these questions. Intermolecular forces are forces that exist between molecules. They affect the physical properties of that species. Dipole-dipole forces are a type of intermolecular force. They are electrostatic interactions of permanent dipoles in molecules that cause the partially positive end of one molecule to be attracted to the partially negative end of another. Great work, everyone! Have your teacher check your examples of intermolecular and intramolecular forces to make sure you understand the difference. In today's lesson, we discussed intermolecular forces. We learned that there are several different types of intermolecular forces, including dipole-dipole forces, hydrogen bonding, and London dispersion forces. Dipole-dipole forces are the attractive forces between the partially positive end of one molecule and the partially negative end of another. We learned that these forces affect the boiling point of substances by increasing the amount of energy that is required to break their molecular bonds. The weaker the dipole-dipole forces, the lower the boiling point. The higher the dipole-dipole forces, the higher the boiling point. In our next lesson, we will learn about hydrogen bonding. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.